Good morning, my dear students. Welcome back. Our chapter electricity, and we studied about series and parallel combination of resistors, and we were dealing with some question answers, and we completed one problem in the last class. And today we are going to the next question, that is, what are the advantages of connecting electrical device in parallel with the battery instead of connecting them in series? Okay, what are the advantage? Okay, let us write the answers. You write the answers. In case of parallel circuit, it divides. In case of parallel circuit, it divides the current through electric gadgets. There is no division of potential difference V. Then the total resistance in a parallel circuit is decreased. Then it is helpful practically when each gadget has different resistance. And require different current to operate properly. And what is next question? How can three resistors of resistance 2 ohm, 3 ohm and 6 ohm be connected to give a total resistance of A 4 ohm, B 1 ohm? Okay, let us see. It is given that the resistors, the value of resistance are the value of resistors are 2 ohm, then 3 ohm and 6 ohm. We want to connect it, and the total resistance should be 4 in the case of A, and in the case of B it should be 1 ohm. How to connect it? And in the case of first, we are giving the solution. How we will do that? Any idea? Here, to get 4 ohm by using this one, let us take it as 2 ohm resistors are as R1 and R2 3 ohm and R3 6 ohm. Okay, and R2 and R3, that is R2 and R3, we are connecting in parallel. Then what happens? And R1 we are connecting in series. Okay, R1, R2 and R3 connected in parallel, and R1, R2 and R3 are connected in parallel and R1 in series. So, in the case of resistors in parallel, we are having the equation 1 by Rp is equal to, or 1 by R is equal to 1 by R1 plus 1 by R2. Okay, here in the case it will become, here which are the resistors connected? R2 and R3. So it will come R2 and R3. So we will get 1 by R2 value 3 plus 1 by 6. That is 1 by R is equal to 1 by 2, that is 2 ohm. Okay. So, in the case of series, what happens? In the case of series, what happens? Series already, the parallel we are having, the resistors in series, what happens? How we are adding? R1 plus R2, which will give R1 is, that is the resistors in, no, R1 is 2 ohm and R2, that is the resistors in parallel. We got 2 ohm. Okay. And the total resistance is 4 ohm. We got the answer. Understood? Understood. First, R2 and R3 are connecting in parallel. Then we are finding the value. Then we are connecting R1 in series. Then we are finding the value of resistance in series. And in the case of B, how we will find B? When this is R1, this is, sorry, not this one, R1, R2 and R3. We are going to connect all the resistors in parallel. R1, R2 and R3 in parallel. How we will find the resistance? 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Is it not? Then we will give the values 1 by R1, 1 by 2 plus 1 by R2, 1 by 3 plus 1 by 6. Sir, no? Then we will get the answer as 1 ohm. Okay, that is what we have to find. Yes or no? That is the answer which we have to find. So, what is next question? What is the highest A, highest, B, lowest total resistance that can be secured by combination of 4 coils of resistance, 4 ohm, 8 ohm, 12 ohm and 24 ohm. Okay, let us see what are the highest and lowest resistance which we are getting. Okay, which are the resistance, the coils, the resistance of the coils? 4 ohm, 8 ohm, 12 ohm, 24 ohm. And first we have to find highest. Okay, highest. Okay, 1 second. So, to find the highest what we will do? We will connect it in series and check. We will connect in series. We will connect the resistors in series. Which are the resistors? Resistors of 4 ohm, 8 ohm, 12 ohm and 24 ohm. And resistor sum is equal to, in series is equal to R1 plus R2 plus R3 plus R4. So we will get 4 ohm plus 8 ohm plus 12 ohm plus 24 ohm. Then we will get 48 ohm as answer. This is the highest resistance which we are getting. Okay. And for the lowest, what we can do? Lowest. Let us connect in parallel. So, the equation to find the resistance of resistors connected in parallel, 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. So, we are having 1 by R1 as 1 by 4 plus 1 by 8 plus 1 by 12 plus 1 by 24. Then we will get 6 plus 3 plus 2 plus 1 by 24 by R is equal to 12 by 24. 1 by R is equal to 1 by 2 is equal to 2 ohm. We got 2 ohm. Two ohm as the answer. This is the lowest which we are getting. So, the question answers till there is completed. So, let us move to the next topic, that is heating effect of electric current. Heating effect of electric current. What is the source of electrical energy in a circuit? We know that a cell or battery is the source of energy in an electric circuit. Then the chemical reaction within the cell, generates the potential difference. The chemical reactions between the cell generates the potential difference between its two terminals. It is having positive and negative terminal. The chemical reactions within them generates potential difference between both the terminals, and it will allow the motion of electrons to flow. The motion of the electrons is responsible to the flow of electric current through a resistor or a combination of resistors. Then, to maintain the current, the source has to be keep expending its energy. Okay. To maintain the current, the source has to expend its energy. Then where does the energy go? We know that while we are using any electric gadget like fan or electric bulb, some part of the energy will used for example, we are thinking a fan, some part of the energy, most part of the energy will be used for the rotation of blade, or in the case of bulb, some part of energy will be used for burning the filament. Where does the other goes? The rest of the energy goes? Where it goes? Rest of the source, what happened to it? The rest of the energy may be expanded as heat, or it will raise the temperature. Did you notice that? Did you not notice it in your daily life? You are using a fan in your home, and ceiling fan, and after you are using it for 2 hours or 1 hour, you just touch on the center side of the fan, you will feel some heat. So also bulb, you check. So in case of a source is using in a gadget, the major part will be using for the useful operation, while some part of the energy is used for the raising or expended to the heat or rising the temperature. Then in some cases, in some gadgets, only configuration of resistors, other than resistors nothing is connected. Okay, can you say any example for that? Can you name any example for that? Only a configuration of resistance is connected in that. Can you name? If we are connecting a configuration of resistance only, the source energy continuously get dissipated in the form of heat. Okay, if a configuration of resistance is only there, it will be it will continuously dissipated or the heat will be released. Okay, this is known as heating effect of electric current. Okay, this is known as heating effect of electric current. That means more resistance are connected. The configuration is having more resistance only. The heat is produced more. Okay, so it is purposefully used in some gadgets in our home. You are using iron to iron your shirts or your pants or your uniforms. That iron is using this technique. Okay, and also heater. Okay, it is only resistors. Okay, only resistors are connected to the battery in that case. Okay,